All right, we have three basic examples here of relationships between x and y, and we're going to find in each case find dy dx implicitly. Again, when I say find it implicitly, that's unofficial language. I mean using implicit differentiation. All right. So what's our rule? Go term by term. If a term does involve y, then you need a factor of dy dx. If a term does not involve y, the derivative as usual. All right, so term by term, the derivative of 6x is simply 6. The derivative of a linear term is the coefficient. Linear term. Linear means exponent is 1. The derivative of a linear term is the coefficient. All right, this term does involve y, so the derivative is as usual, 14y to the first. But now I need to multiply by dy dx. If a term does involve y, multiply by dy dx is equal to, term by term, derivative here is 9x to the second. This does not involve y, so there we go. And then the derivative of y is 1, but we need dy dx. It is convenient, you don't need to, it is convenient to write the 1 because you know you're going to factor here pretty soon anyway. All right? Now the next piece, once you have all the derivatives, all the dy dx terms go to the left. All the terms that do not have dy dx go to the right. So you separate the terms. 6, what happens to the 6? The 6 does not stay here. The 6 needs to move to the other side. So I'm going to just, as we go, 6 comes over here, and when it crosses the line, becomes negative 6. This stays where it is because it does involve dy dx, so it stays on the left-hand side. 14, so this implies 14y dy dx. This 9x squared stays where it is. I'll talk about that in just a moment. But this needs to move to the other side because it does have dy dx. When you cross the line, this becomes positive 1 dy dx. Then factor out dy dx. And this is where we're going to use our little shortcut version. Dy dx is equal to, it's going to be this big fraction. The numerator is everything that's over here to start with. So that's the negative 6 plus 9x squared. And the denominator, how do we cobble together the denominator? The denominator is whatever is left over after you factor out this dy dx. Well, when you factor out dy dx, what's left behind is the 14y and the plus 1, and it's all over but the shouting. So like I said, this doesn't take nearly so long if you don't need to explain it while you're doing it. Now, another small detail is this. This 9x squared is already over here. When you subtract this 6, you may, if you wish, write this as 9x squared minus 6. In which case your answer doesn't look like this. Your answer would look like 9x squared minus 6 over this same thing. All right? I don't care which of those you pick. Those are both correct because this and this are the same thing. But this is what stymies students, and really, if I can be honest with you, this is what drives instructors batty. Because I'll get students that the student will write this down on the homework. And they check the answer in the textbook, and the textbook has this. And the first thing that comes to the student's mind is, what did I do wrong? And the second thing that comes to mind is, I need to ask the instructor what I did wrong. And very often what students say is, why is the answer in the book wrong? Well, it's not. You need to know that these are the same thing. Negative 6 plus 9x squared is the same thing as 9x squared minus 6. It doesn't matter what order you write this. If the textbook had this, if the textbook had 1 plus 14y, that's the same thing. It doesn't matter what order you write these. So the order doesn't matter so long as the negative stays with the 6 and the positive stays with the 9. The order doesn't matter. There are many different possible sequences you can write this thing with. I don't care which one you pick, and you should be able to figure out, because you have a vast knowledge of algebra now, you should be able to figure out that, yes, this is the same as that, and it's the same as several other varieties. So I don't care which form you pick, just get a correct version, put a box around it, and be proud of it. All right? So, example 2. Let's get rid of this guy. I'm going to put this back to the correct version now, so the dean doesn't bark at me. There we go. And so negative 6 plus 9x squared, all over 14y plus 1. That's the leftovers from this factoring. All right. Number 2, same song, second stanza. If a term does involve y, multiply by dy dx. Well, there it is. That does involve y. The derivative of sine of y is cosine of y, but you need dy dx because y was involved. This term does not involve y. The derivative is as usual. The derivative of tangent is secant squared. Is equal to, I'm going to need to steal some space here. The derivative of y squared is 2y dy dx. Put my little box there, we go. Now we're back to the same process. Dy dx go to the left. Without dy dx goes to the right. So this stays where it is. Just do it one at a time. Cosine y dy dx. This has to move to the other side. This has to move to the left-hand side. So I'm going to put the negative secant squared on the right-hand side, and this needs to move to the left-hand side, becomes negative 2y dy dx. And then we're going to factor out dy dx. But you can just go ahead and go directly to the answer. The numerator is whatever's over here, negative secant squared of x. The denominator is whatever's left over from this factoring. If you factor out dy dx, what's left over? Cosine y minus 2y. And there are multiple ways to write this. Any one of the multiple ways to write this is fine. But this is correct, and that's good enough. All right? I'm going to move example 3 down here below the little box here. I have x squared plus y squared equals 25. This one comes about very frequently. We'll see in the next section. Same procedure as before. This derivative of x is simply 2x. This derivative of x squared is 2x. Derivative of y squared is 2y. But we don't stop there because we need dy dx. Derivative of a constant is 0. This term does involve dy dx. It stays on the left. This does not involve dy dx. It moves to the right. So this moves to the right-hand side. This stays where it is. Move that to the right-hand side. Leave this alone. Now there's no factoring. There's just the dividing. Solve for dy dx. It is this, which is already over here, and divide by 2y, which is over here. You may, as far as I'm concerned, you may simply put a box around that and leave it there. You may, if you wish, cancel the 2's. I don't care which of those you pick. God bless you. If you want to cancel the 2's, there we go. And so either one of those is fine by me. All right? So that's the basic process. Now the next video we'll talk about how do you do the derivatives when product rule gets involved, or if quotient rule gets involved, or if chain rule gets involved. So implicit differentiation with all the other rules for derivatives we know. We've seen you can include the trigonometric functions. Later on in the course, when we get them, you'll be able to include logarithmic functions or exponential functions. So implicit differentiation. So far, all we've done is dy dx. And we'll be able to do some other variables here soon in the next examples. So this is the basic work. None of this involves product rule, quotient rule, or chain rule. And all of this involves dy dx. So we'll see some more variations on the theme in the next video.